Welcome to the fourth lecture in riparian function and management. In our last meeting, we began discussing some common riparian language. You were introduced to parts of a creek, to stream order, for example, first order streams have no perennial tributaries, to stream flow and how it is measured and recorded, to Rosden's channel classification, and we talked about sinuosity or meander, the crookedness of a channel. We talked about gradient or slope, which is expressed as a percentage calculated by vertical elevation of change in channel length. Also was discussed erosion deposition, two opposing forces at work in a stream, and width-depth ratio, common relationships between depth, width, and meander length. In this lecture, we will continue developing understanding for riparian terms, processes, and dynamic. In Texas and elsewhere in the United States, we call the area of the landscape that drains together to a point a watershed. This is the term that is widely used by agencies and institutions. In other parts of the world, especially in drier climates, they call this a catchment. Semantics do count. A shed seems to speak to water leaving the landscape, while catchment evokes an image of water being caught or captured by the landscape. A stream's position in the landscape and watershed catching setting is a strong determinant of that stream's ability to develop and to support significant riparian and wetland resources. Several stream classification systems have already been discussed. In the last lesson, we talked about stream order, basically the number of tributaries it has, and we talked about channel shape, Rosden's classification, as well as discussed meander types, more crooked and more straight. In this lesson, we will be discussing classifications based on location within the water catchment and classification based on the source of stream flow. The purpose in classifying is to better describe both the landscape and watershed or catchment setting, and to better understand the functional potential of a given stream's riparian area. We are spending much effort in Texas planning how to keep rivers flowing and how to prevent the overdrafting of aquifers. Most large streams have at least 3 general reaches in the reach classifications. A sediment production reach, this area is often the headwaters of a river. There's the sediment transport reach, which is usually the middle of each. And there's the sediment deposition reach, which on a large river is near its mouth and crossing flat country. Knowing the reach classification can aid in understanding the stream's plant communities and overall function. An important factor in understanding a particular stream or reach and its riparian condition hinges on the presence of water. Therefore, knowing what kind of flows it usually receives is very helpful. Ephemeral streams flow only in direct response to storm runoff and are not connected to the groundwater table. Seasonal or intermittent streams flow occasionally and may flow for extended periods of time, enjoying a temporary association with groundwater. The riparian function we will be exploring in this course applies to perennial streams, those that flow most of the time except during severe drought and are connected to a groundwater table. Perennial streams can contain interrupted reaches. In southwest Texas, it is commonplace for perennial streams to lose all of their flow to aquifer recharge as they cross over certain geological features called recharge zones. Perennial streams can display seasonal or ephemeral conditions through a given reach. Perennial streams can also be interrupted temporarily or permanently by overpumping, channel incision, climate change, and dams or surface impoundments. Only a few of the riparian concepts we will explore in this class apply to ephemeral streams. Still, processes like energy dissipation and sediment trapping may be noted and can be enhanced through management along ephemeral streams. An ephemeral draw can hold the capacity to transport runoff and maintain a channel, but not a groundwater connection. Seasonal streams hold more potential for riparian function than ephemeral streams, but cannot be expected to function in all respects because they lack a permanent connection to groundwater. They may flow only at certain times of the year when groundwater levels are high and springs are discharging. In higher elevations, seasonal flow may come from melting snow. The key aspect of perennial streams in supporting riparian function is their connection to a groundwater table. Perennial streams flow above the ground all the time, except during severe drought. Groundwater pumping across the Carrizo Aquifer has lowered water tables between 100 to 300 feet across the landscape. Many creeks that were once perennial are now seasonal or ephemeral. Their classification has been altered. The creek pictured here, despite a recent history that documents perennial flows and the presence of a well-defined stable channel, does not hold water. In evaluating the condition of riparian areas, it is important to recognize limitations to function that may be outside of our control or our ability to manage for. The term riparian potential is used to qualify possible limitations to improved function. Potential is defined as the highest ecological status a riparian wetland area can attain, given no political, social, or economical constraints. Also known as Potential Natural Community, or PNC. The U.S. Forest Service defines PNC as the biotic community that would become established if all successional sequences were completed without interference by humans under present environmental conditions. Natural disturbances are inherent in development of a PNC. Political, social, or economical realities are thought to constrain a return of the previous water table levels across the western Carrizo Aquifer. These realities are compounded by the fact that the Carrizo Aquifer is very slow to recharge. The perennial potential of many streams may have been altered permanently. Capability can be defined as the highest ecological status an area can attain given political, social, or economic constraints, which are often referred to as limiting factors. Here are some visual examples of natural potential for riparian sites and the capability for riparian sites given major human influences. When expecting recovery, it is important to understand the potential of and any factors influencing its capability. The Nueces River Basin, for example, crosses 3 recharge zones to major aquifers. These recharge zones are locations where the aquifer outcrops or come near to the surface and received recharge from stream channels that they cross. In the upper portion of the basin, the rivers recharge the Edwards Aquifer. As you travel along Highway 90 between Sabinal and Del Rio, you cross a number of interrupted reaches of perennial streams. They are still classified as perennial streams, but some now lose all their flow seasonally for 15 to 20 miles as they cross over the recharge zone of the Edwards Aquifer. Pictured here is the bed of the Nueces, about 1 mile upstream of the Highway 90 bridge. The cracked and holy rocks are often referred to as karst features. These karst features are visible in the riverbed and are indicative of Edwards recharge sites. Sometimes the loss of stream flow to groundwater aquifer is less dramatic, and sometimes a stream can lose flow to geologic features that are not necessarily major aquifers. Streams with large alluvial deposits can seem to dry up, but have actually had a portion of their surface flow begin to move below the surface. Farther downstream, all or a portion of these subsurface flows can return to the channel without entering an aquifer. A stream can also gain flow from groundwater being discharged into it through springs or seeps from other sources. Pictured here is a map of all current gain and loss data along streams originating in the Edwards Aquifer contributing zone. Considered together, these groupings of green dots can indicate a gaining reach, and the groupings of red dots a losing reach. Still, some reaches can morph into losing or gaining depending on flow rates and groundwater conditions. So, why is this important? Flow classification is important to riparian function because much of the functional condition is predicated on the permanence of a groundwater connection. A stream that lacks a permanent connection to groundwater cannot be expected to maintain the same level of function as the one that does. Sometimes, but not always, perennial streams or reaches are indicated on USGS topographic maps as solid blue lines, while seasonal and ephemeral streams will be shown as dashed or dotted blue lines. Some USGS topo maps were never ground truthed, so they offer a clue, but not an entirely reliable designation for flow classification. Also, many landscapes have been altered since USGS topo mapping was done, and some streams have evolved from one classification to another. A once perennial stream, through poor management and loss of riparian function, can be transformed into a seasonal stream that only runs during periods of good rainfall. Conversely, a creek that has become seasonal can recover and become a perennial stream with an improvement in riparian function and water storage capacity. Pictured here is a topo map of a location along Alameda Creek near one of our class field trip sites. On this map, Alameda is portrayed as a perennial stream, solid blue line with a braided channel. The dappled tan color shown on the map in the creek's channel indicates the presence of alluvial material, possibly sand or very small grain sediment. Larger rivers are usually depicted on USGS topo maps with wide, solid blue lines. Sediment is responsible for another 1/3 of the equation. A stream's job is to move sediment and water. Bed load is a term used commonly to describe the material transported by a stream at and above bankfull discharge. The rock particles and dissolved ions carried by streams are called the stream's load. Stream load is divided into 3 categories. First, you have suspended load. These are the particles that are carried along with the water in the main part of the streams. The size of these particles depends on their density and the velocity of the stream. Higher velocity currents in the stream can carry larger and denser particles. Second is bed load. Coarser and denser particles that remain on the bed of the stream most of the time, but move by a process of saltation or jumping as a result of collisions between the particles and the turbulent eddies. Note that sediment can move between bed load and suspended load, and the velocity of the stream changes. Last is dissolved load. These are ions that have been introduced into the water by chemical weathering of rocks. This load is invisible because the ions are dissolved in the water. The dissolved load consists mainly of HCO3 -2 or bicarbonate ions, as well as other long equations. These ions are eventually carried to the ocean and give the oceans their salty character. Streams that have a deep underground source generally have higher dissolved load than those whose source is on the Earth's surface. The maximum size of particles that can be carried by a suspended load by the stream is called stream competence. The maximum load carried by the stream is called the stream capacity. Both competence and capacity increase with increasing discharge. At high discharge, boulder and cobble-sized material can move with the stream and are therefore transported. However, at low discharge, the larger fragments become stranded and only the smaller sand, silt, and clay-sized fragments will move. When flow velocity decreases, the competence is reduced and sediment drops out. Sediment grain sizes are sorted by the water. Sands are removed from the gravels, muds from both. Gravels settle in the channels. Sand drops out in nearby channel environments, and silt and clay drape floodplains away from channels. For your homework on RF4, in today's lesson, we covered more terms and discussed some of the concepts needed to communicate with common language about riparian areas. So, for homework and prep for our discussion on Friday, you are asked to revisit the stream gauge from your RF2 homework and predict if your stream at the gauging location is perennial, seasonal, or ephemeral. You are also asked to view the topo map of that site carefully and report any observation relative to the channel, the substrate, etc., that can be estimated from the map.